name. What's in a name? That which we call a rose by any other name would smell as sweet. In case you didn't catch that reference, that's William Shakespeare, Romeo and Juliet. Insert swoon. Anyhow, today we're going to be talking about covalent bond naming. So now that we know about covalent bonds, we know how to draw covalent bonds, we know that they're made up of nonmetal atoms. Now how do we name them? How do we name all of these covalently bonded molecules? By the end of this video, you should be able to employ the rules that I teach you today for naming any covalently bonded molecule you happen to come across. But first, before we go into the steps of what you need to do, here are some common names that you will probably bump into. Even though they should be called something else according to the rules that we're going to learn today, we've basically gone into this habit of using these names for so long that it doesn't matter that it's not technically the right name. We just use these common names because that's the old habit, and old habits die hard. Water is H2O, and methane, CH4, is, the cow farts that are over there. Ammonia, NH3, hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. So even though they might have a better, more scientific name that we should be using, these are the common names that everybody else calls them, therefore you should know what they're talking about if they use these common names instead of the scientific name. Before we jump into the rest of the naming, just a little bit of a brainstorm. Given the following words that you've likely heard of at some point: tricycle, triceratops, triangle, trio, trilogy, triplets, triathlon. What do you think tri means? The prefix is something you put in front of all those words to symbolize a number. Tri means 3, in case you didn't get that. It also kind of reminds me of the word drei in German. Tri, drei. They sound very similar, so it's convenient for us German speakers. Anyhow, tri as a prefix, if it's in front of anything, means 3. So tricycle, there's 3 wheels. Triceratops, there's 3 horns. Triangle, there's 3 points. Trio, like the 3 Musketeers. Trilogy, that's 3 books. Triplets, 3 babies. Hi, Chihuahua. It's hard enough with one, I tell you. And triathlon, 3 separate things you do, like land, sea, I don't know, what else, flying. Me personally, I'd probably pass out in a triathlon, so kudos to all of you that can make it. Why am I bringing this up? Because covalent bonding, it has everything to do with these kinds of prefixes to tell you how many atoms there are. So it's time to level up and name these covalent molecules. As a reminder, covalent molecules only occur between nonmetal atoms. That is the definition of covalent molecules. And another reminder, metalloids do count as nonmetals in this scenario. These are the prefixes you must know. You absolutely must know these or be familiar with them in order to name covalent compounds. The prefix mono means 1, di means 2, tri means 3, tetra is 4. Now I have bolded those first 4 because you're going to see those more often. Those are more common. Then afterwards, penta is 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. If you have these memorized, naming covalent compounds will be a breeze. So for example, CO2, carbon dioxide. You've probably heard it called that a number of times, but never realized that you were actually explaining the name of a covalently bonded molecule. 1 carbon, carbon, dioxide, 2 oxygens present, using these prefixes. So here are your steps for success. Step 1. For naming covalent compounds, write the full name of the first element with a prefix corresponding to the number of atoms that element has. So if you have an element with 2, you would write di and then whatever the element's name is. Or 3, tri, whatever the element's name is. Now notice the examples I gave were for 2, 3, and anything beyond. If the first element only has 1, you do not need to write mono. Mono is only used if the second element has a single atom thereof. Remember in the example of carbon dioxide, I didn't say monocarbon dioxide, I said carbon dioxide. Since I only said carbon, it's implied that there's only one carbon. However, if there were two carbons and two oxygens, I would have to specify dicarbon dioxide as opposed to carbon dioxide. Step 2 is to take the second element and write ide, I-D-E, ide, as the ending, and choose a prefix that corresponds to the number of atoms of that second atom present. So for example, H2O, which we use the common name for as water, is technically called dihydrogen monoxide. There's two hydrogen atoms, monox, one oxygen, ide. And now I've ended that whole thing in ide. Notice I didn't say dihydride monoxide. The ide only goes at the end of the second element's name. So now let's give these a try. If we start with CH4, don't fall for my trap. Don't fall for my trick. Did you fall for it? Did you start counting atoms? CH4 is one of those ones that you should know the common name for. Great if you can figure out the scientific name with the prefixes for it, but we call it methane. CH4 is known commonly as methane. So don't go off into the carbon tetrahydride thing. Methane. Second one, NO2. There's one N, two O's. So we would say nitrogen. It's not mononitrogen. It's just nitrogen. There are two oxygens, and it's the second atom present, so we have to end it in ide. So we'd say di-ox for oxygen, ide. Nitrogen dioxide. We also have H2S. There are two hydrogen atoms and one sulfur atom. We would say dihydrogen, two hydrogens, and there's one sulfur. The sulfur needs to end in ide, so we would say monosulfide. Last but not least, we have one sulfur atom and 6 fluorine atoms. Sulfur is the first one that is alone. We do not need to say monosulfur. We just say sulfur. And there are 6 fluorine atoms. Since fluorine is the second atom, it needs to end in ide, so it would be fluoride, and has to have a prefix that shows 6 of them present. So that would be sulfur, hexa, fluoride. See how if you know the prefixes, this would be really easy? Now the reverse is just as fun. You could be given a name and you can draw what the molecule would look like based off of the name, because it tells you how many atoms there are of each present. So since the prefixes designate immediately the number of each atom, you can just write it out. Easy peasy. So let's try it. Carbon monoxide. Carbon is a single C, so we'd have a C. And then monoxide means there's one oxygen. So CO. Great. All done. CO. Nitrogen trihydride. Nitrogen is singular by itself, so we would write an N. And then we have tri for 3, hydride, hyd for hydrogen, ends in ide, so 3 hydrogens. N, and then H, 3. But I thought you said that that was a common name one and you're never going to call it nitrogen trihydride. You're right. You're right. I totally got you. Nitrogen trihydride is technically ammonia. We're never really going to refer to it as nitrogen trihydride, but I wanted you to get the practice anyways. It is ammonia as its common name. Dinitrogen trioxide. Di means 2, so 2 nitrogens is the first placeholder for the atoms. And then tri, ox for oxygen, ide. So 3 oxygens. So the way you would write this out is N2, so N subscript 2, O subscript 3. Make sure that when you're writing these out, you write them out with the number as a subscript. So at the bottom or the foot of the atom that you wrote the symbol for. You don't want to put them as a superscript, and you don't want to make them the same size as your atom itself when you write out N2O3. Or anything that has a number associated with it. So overall, your molecules would look like this. 1 carbon, 1 oxygen, 1 nitrogen, and 3 hydrogens. Notice how I make it a little tiny 3 at the bottom. I am not doing this, and I am not doing this. You put the number as a subscript next to the letter. So these are no-nos. This is good. Dinitrogen trioxide, 2 N's, a 2 next to the N in small subscript. and an oxygen with a 3 after it. As with anything in life, there are always exceptions, even as annoying as that may seem. So here's one of the exceptions for naming. When it comes to elements, you might end up with more than just one of the same atom bonded together to make an element. So if that's the case, you're going to call the entire molecule or the entire element itself by the element's name alone. So for example, O2, a diatomic, is just oxygen. You wouldn't say dioxide, just oxygen. N2 is just nitrogen. It's a diatomic. You wouldn't say dinitride or dinitrogen. You would not say that. It's just nitrogen. S8 is just sulfur, not octasulfur, not octasulfide, just sulfur. You ready to practice? We're going to go through all of these together quickly and apply this naming and see if you understand it. If you want to give these a try before seeing what the answers are, the full worksheet is linked in the description below, so print it out, maybe try and fill it out, pause the video here, and then see if you got them right. All right, let's put your knowledge to the test. Can we do this? Hopefully you gave these a try on your own before you see me work them out to really test your own understanding of this material. So there's a few trick questions in here that might not even be covalent molecules. Remember, we're only going to use these steps if it happens to be a covalent molecule, and covalent molecules can only have non-metal atoms. So if any of these have metal atoms in them at any point, we can't name them according to the rules we just learned. It's going to have a different kind of rules that we'll learn later, but you can't use these. They're not the same. So the first practice question is asking you to name NaBr. Hopefully you looked at your periodic table and right away noticed that Na, sodium, is a metal. You cannot name that according to the naming scheme and steps we've just learned. You cannot do that. So that would be not applicable. H2S. Those are both nonmetals. It's a covalently bonded molecule, so we can use the steps we just learned. There are two H's, so that would be dihydrogen. And there is one S, mono, sulf, and then we end in ide. Dihydrogen monosulfide. P2O5. Both phosphorus and oxygen are nonmetals, so we can name according to the scheme we just learned. There are two phosphorus atoms, so we would say diphosphorus. And there are 5 oxygen atoms. Remember, it's mono, di, tri, tetra, hepta. So this would be hepta, ox for oxygen, and end in ide. We have Br3. All of those atoms present are nonmetals. So we have one boron, so we're going to say monoboron. Just kidding. Remember the first one we don't say mono for. It would just be boron. Boron. And there are 3 bromine atoms. So that would be tri-bro-mide, and in the ide. SO2. There's 1 sulfur and 2 oxygens. These are both nonmetal atoms, so we can name it according to these steps. Sulfur, no mono, just sulfur, and 2 oxygen atoms. Dioxide. NH3. Don't fall for my trick. That's going to use a common name, ammonia. Like the stuff that makes your head feel funny after spraying Windex, or the smell of your pee, ammonia. VO2. Vanadium is a metal. We need things that only have nonmetal atoms. So this is a not applicable option. PBS, and not like the station for kids. PB stands for lead. That's a metal. We can't use these rules for anything that has metal atoms, only nonmetal atoms. So this is also not applicable. And if I just scoot out of the way here for a second, that one is N2O3. There's 2 nitrogens, 3 oxygens. So that would be dinitrogen, tri-ox, and then end in ide. And last but not least, there's SiO2, silicon and 2 oxygen atoms. Now silicon is along that stair step. It's known as a metalloid, and metalloids in our case can count as nonmetal atoms. So we can use the steps here to name SiO2. That would be silicon, And there are 2 oxygen atoms, so di, ox, and an ide always. I hope you got those all. Let's try the reverse. There's sulfuric acid. That's another trick one. We use that as a common name, and that should be H2SO4. That's one you just have to memorize. You got to know it. Sulfuric acid is H2SO4. Diboron tetrabromide. That means there are 2 borons and 4 bromines. So we need boron B, and we need to put a 2 at the bottom. And we need bromine, Br, and we need to put a 4 at the bottom for tetra. That third one likely has you stumped. Ammonium, what's that? Kind of sounds like ammonia, but it's not the same thing. Don't be fooled by it. This is something called a polyatomic ion. Ions is something we're learning later. Even though they're all nonmetal atoms here, this is one of those weird exceptions where it's actually multiple atoms together creating an ion structure instead. They have a different naming scheme entirely. So this one would be a not applicable for what we're trying to do right now with our prefixes. Moving on to number 4, carbon tetrachloride. There's 1 carbon, and we know that there are 4 chlorines. So we'll have Cl and then a little 4 at the bottom. Whew, that next one looks nasty. Tetraphosphorus triselenide. Selenide is for selenium, and there are 3 of the selenium atoms and 4 of the phosphorus atoms with the tetra. So let's draw P and then 4 for tetra, phosphorus, and Se for selenium, and it has 3 of those atoms. Disilicon hexabromide. We have 2 silicon atoms and hexa 6 bromine atoms. So 2 silicons, Si2. Bromine has 6, Br6. Calcium phosphide. Hopefully you knew right away that calcium is a metal. Because of that, this is not applicable. We're not going to write out the chemical with metal atoms present using covalent bond nonmetal naming schemes. It doesn't work. Different rules apply. Tetrasulfur dinitride. There are 4 sulfurs, S4, dinitride, 2 Ns. And last but not least, dinitrogen trioxide. There are 2 nitrogens, N2, and there are 3 oxygens, O3. I challenge you to open up any of your medications at home and look at the big, long names that are inside the chemical labels for any of them. Take a gander at all of the prefixes used throughout that organic molecule that is likely any drugs you may have at home. Remember to click that like button and help a teacher out by subscribing to my channel. Hope your day is just ducky.
No ducks, no glory.